Welcome you all. I am Dr. Jagan, Associate Professor, Electronics and Communication Department from Rohini College of Engineering and Technology, Kanyakumari. So this video I have discussed about ADA wireless sensor networks.
Security in wireless sensor networks. Wireless sensor network is a special type of network. The sensor networks based on a inherently broadcast wireless medium are vulnerable to a variety of attacks. Security is a prime importance in sensor network because the absence of central authority, random deployment of nodes in the network and nodes assume a large amount of trust among themselves during data aggregation and even detection. From a set of sensor nodes in a given locality, only one final aggregated message may be sent to the base station. So it is necessary to ensure that communication links are secure for data exchange. Cryptography solutions based on symmetric or public key cryptography are not suitable for sensor networks due to these high processing requirements of the algorithm. So need special type of protocol to ensure the security in sensor networks. Network security requirements. The security services in a wireless sensor network should protect the information communicated over the network and the resources from attacks and misbehavior of nodes. The most important security requirements in wireless sensor networks are listed below: data confidentiality, authentication, data integrity, data freshness, availability, and organization. Confidentiality. Data confidentiality requirements is required to ensure that sensitive information is well protected and not revealed to unauthorized third parties. The confidentiality objective helps to protect information traveling between the sensor nodes of the network or between the sensor to the base station from disclosure. Since an adversary having the appropriate equipment may eavesdrops on the communication. By eavesdropping, the adversary could overhear critical information such as sensing data and routing information. Based on the sensitivity of the data stolen, an adversary may cause severe damage since he can use the sensing data for many illegal purposes. Furthermore, by stealing routing information, the adversary could introduce his own malicious node into the network in an attempt to overhear the entire communications. If you consider eavesdropping to be network level threat, then a local level threat could be a compromise node that an adversary has in his possession. Compromise nodes are a big threat to confidentiality objectives since the adversary could steal critical data stored on nodes such as cryptographic keys that are used to encrypt the communication. Authentication. It ensures that the communicating node is the one that it claims to be. An adversary cannot only modify data packets but also can change a packet stream by injecting fabricated packets. It is therefore essential for a receiver to have a mechanism to verify that the received packets have indeed come from the actual sender node. In case of communication between two nodes, data authentication can be achieved through a message authentication code MAC computed from the set secret key. Data integrity. The mechanism should ensure that no message can be altered by an entity as it travels from the sender to the recipient. Data freshness. It implies that the data is recent and ensures that no adversary can replay old messages. This requirement is especially important when the wireless sensor nodes use shared keys for message communication, where the potential adversary can launch a replay attack using the old key as the new key is being refreshed and propagated to all the nodes in the wireless sensor network. The no one's or time specific counter may be added to each packet to check freshness of the packet. Availability ensures that services and information can be accessed at the time that they are required. In sensor networks, there are many risks that could result in loss of availability, such as sensor node capturing and denial of service attack. Lack of availability may affect the operations of many critical real-time applications, like those in the healthcare sector that requires a 24/7 operation that could even result in the loss of life. Therefore, it is critical to ensure resilience to attacks, targeting the availability of the system and find ways to fill in the gap created by the capturing or disablement of the specific node by assigning its duties to some other nodes in this work. Self-organization. In wireless sensor network, no fixed infrastructure exists, hence every node is independent, having properties of adaptation to the different situations and maintains self-organizing and self-healing properties. This is a great challenge for security in wireless sensor network. Time synchronization. Most of the applications in sensor networks require time synchronization. Any security mechanism for wireless sensor network should also be time synchronized. A collaborative wireless sensor network may require synchronization among a group of sensors. Localization. For data transmission, some applications use location information of the sync node. It is important to give security to the location information. Non-secure data can be controlled by the malicious node by sending false signal strength or replaying signals. Scalability. Hundreds of thousands of nodes are deployed in a network carrying out distributed operations. Because of this explosive proliferation of sensor nodes, scalability is becoming an important requirement in wireless sensor network. Wireless sensor network must be scalable to provide capacity or additional nodes. New nodes insertion and old nodes removal should be easily with no bad impact over the network operation. Issues and challenges in security provisioning. A strong routing protocol can only protect the network from various malicious activities. Designing a strong security routing protocol for wireless sensor network is a very challenging task. Wireless sensor network must have the richest set of different protocols to carry out applications requirements. A wireless sensor network protocol must handle the hostile environment. Routing protocols should provide a high throughput and a decreased packet loss ratio. Routing algorithms should handle mobility and dynamic changing behavior in wireless sensor networks. Unreliable wireless media can drop packets. Routing protocols should prevent packet loss. Designing a new routing protocols for wireless sensor networks should consider the following security and privacy. Node mobility, coverage problem, SAD broadcast radio channel, insecure operation environment, lack of central authority, lack of association, limited resource availability, physical vulnerability, quality of service. Programming wireless sensor networks on node mobility. The mobility sync node is used to collect data from all sensors. A static sync node collects data from all sensors without changing its constant position. A mobile sync node has its own effects on the network. Example given: performance and dynamic change behavior. Routing protocols must provide better connectivity and efficient energy consumption, a controlled flooding mechanism, etc. Coverage problem. Coverage is an important performance metric in wireless sensor networks. It reflects how well the environment is monitored. The surrounding vicinity should be monitored all times to collect data. A dead node cannot forward by packets. Consequently, it degrades network services. Broadcast radio channel. Unlike in wire networks where a separate dedicated transmission line can be provided between a pair of end users, the radio channel used for communication in wireless sensor network is broadcast in nature and is shared by all nodes in the network. Data transmitted by a node is received by all nodes within its direct transmission range. So a malicious node could easily obtain data being transmitted in the network. This problem can be minimized to a certain extent by using directional antennas. In secure operational environment, the operating environments where wireless sensor networks are used may not always be secure. One important application of such networks is in battlefields. In such application, nodes may move in and out of hostile and insecure enemy territory where they would be highly vulnerable to security attacks. Lack of central authority. In wire networks and infrastructure based wireless networks, it would be possible to monitor the traffic on the network through certain important central points such as routers, base stations, and access points, and implement security mechanism at such points. Since wireless networks don't have any such central points, this mechanism cannot be applied in wireless sensor networks. Lack of association. Since these networks are dynamic in nature, a node can join or leave the network at any point of the time. If no proper authentication mechanism is used for associating nodes with a network, an intruder would be able to join into the network quite easily and carry out his or her attack. limited resource availability. Resources such as bandwidth, battery power, and computational power are scarce in wireless sensor networks. Hence, it is difficult to implement complex cryptography-based security mechanism in such networks. Physical vulnerability. Nodes in the networks are equally compact and handheld in nature. They could get damaged easily and are also vulnerable to theft. Quality of service. Quality of service is the function of this application. The proper congestion control provides better quality of service in wireless sensor network. There is a minimum chance of congestion outside the base station area. Congestion near the base station results into channel occupancy, buffer overflow, packet collision, channel contention, high data rate, and minimum nodes life. For better services, minimum congestion in the network is necessary. Congestion avoidance ensures high throughput, better link utilization, minimum delay, energy efficiency, and minimum data rate. Control packets are used to prevent congestion. Programming wireless sensor networks. Programming a large network of highly resource constrained devices that are self-organized and globally consistent with a robust behavior and dynamically changing environment is a big challenge. Thank you.